All right, so good morning. We will do this problem from the chapter of work, power, energy. Now, if you see the problem, this is the crane carrying a weight W and it displaces this weight from this point X to point Y. So the overall displacement of the weight is from X to Y and is given by P. So this is your overall displacement. Now, if you see this problem, okay, it has one component of P, which is Q, okay, so this is your Q, and then it has another component of P, which is the horizontal component, which is, say, R, okay. Now, first of all, I will discuss how do you solve these problems. Okay, this is not a very difficult problem, but a conceptual problem. And initially, when you start work, power, energy, such problems you must do, which are very simple, but help you to keep a good grip on the concept. Okay. Now, the work done is given by, I'm just telling you the general theory first. So, the work done is given by force dot S cos. Okay, so let me just write the vector scalar product first. The work done is a scalar product of force that results in a displacement of S, and therefore the overall work done is F S cos theta. Okay, and how do you interpret this Fs cos theta? What you can do is you can watch my video on the scalar product. It will give you immense clarity. You can solve questions of physics if you have very strong base of vector algebra, okay? And this is a classic example of that. Now, if you have a force like this and you have a displacement caused by this force, which is this, then you can see the work done is the displacement multiplied by, so I will write it as displacement multiplied by the component of the force, which is in this case F cos theta, okay, in the direction of the displacement. So you can see the F has two components. So this could be a mass. You are pulling this mass by 60 newtons, and the angle between the force and the displacement it causes, okay, it reaches here, is, so this moves by 5 meters, and this angle is 30 degrees, okay. Now, if you have to find the displacement, you have to see the components of the force, which are, okay, so these are the components of the force. So this is 60 sine 30, and then this is 60 cos 30. Okay, you can see 5 meter displacement and 60 cos 30 are in the same line, and that is a point. In the same line, the force component and the displacement should be in the same line, or I can say the displacement component and the force should be in the same line. That results in the work done. The component of the force, which is perpendicular to the displacement, will not change the kinetic energy of the body. It will not be able to supply it any work. That's the point. The work is when you're able to supply something to that body, which is, in most of the cases we will see, is kinetic energy. Okay, so be very clear that whenever you solve a problem, you're very, when you read the diagram, the force and the displacement are in the same direction. Now, force could be downward, and displacement can be upward, or the force can be backwards or the displacement can be forward, as in the case of friction, but still the work is done, right? And we will see what happens. So this crane picks up the body from X to Y. Okay, let's see. The weight, right, is in this direction. There is one displacement, which is this. Okay, it's a component of P, and maybe the X component of P. So these have an angle of 90 degree between them. We just noticed that if the angle becomes 90 degree, the work done, if theta is equal to 90, the work done will become 0. If the force is in this direction and the displacement is in this direction, you have no work done actually. Okay, you can't supply kinetic energy to the body. But if you have a situation like this where the direction of the, so this is your weight, right, and this is what the crane has been able to do from x to y. The displacement of the body, real displacement, the displacement where the weight and the displacement are in the same line, is this one. Okay, so therefore the work done is equal to the force, which is the weight of the, so let me just put the magnitude of the weight of the block, which was taken from this to this, multiply by the displacement q as the answer. Okay, this is because q is in vertical direction, q is vertical, and y, the w is also vertical, right? So if you raise the height of this block by using a lift, essentially your work done is getting stored as potential energy. It gets stored. It is not lost because you're working in conservative field. Very importantly, if you notice, the trick of the trade is in vector algebra. That is, you understand vectors pretty well, scalar product. Do small questions on work done to first strengthen your concept of being able to select the right kind of angle to solve the problem of finding the work done. You can have force in many directions. As an example, if I tell you this is the force on a block, okay, and the block, when you applied this force on the block, so this was 5 Newton, the block was going in this direction with certain acceleration, and you continuously applied the force, and finally the body came to a standstill. So the acceleration of the body was 2 meter per second square. You started, and when you applied the force, the initial velocity was 2 meter per second in this direction. Okay, how much work is being done by this force? Okay, now what is happening, if you notice, on this body is, and let's say the angle at which you apply is 60 degree. So there are two components of the force. One component is 5 sine 60. Okay, the other component is 5 cos 60 degree, right? Now you can see 5 sine 60 will have no contribution when it comes to this horizontal direction, because this displacement of the body is in x-axis and this is in y-axis. So the theta is equal to 90 degree. So the work done by this 5 sine theta is equal to 0. Whatever work is being done by this 5 Newton body, which is acting in this direction. Now if you notice, let's say the mass of the body is 1 kg. Okay, now it stopped from initial velocity of 2 meters. So initial velocity 2 meter per second, that was its kinetic energy. Okay, so you did supply some kinetic energy to this body, it had actually, right? And finally it stopped because of this force. This force continuously acted on this body and stopped it. So 5 cos 60 multiply by the displacement, which is in the opposite direction, but they are in the same line. Even if they are in opposite direction, they are in the same line. You can see the displacement is equal to change in kinetic energy of the body. So half m final velocity is 0 initial velocity is 2 meter per second. So 5 multiplied by 1 by 2 into d is equal to minus half m into 4. Okay, so and remember, you can see, right, this sign of negative, so it's a loss of kinetic energy. Okay, and I can also write here because they're in opposite direction. So let's say, so mass is 1 kg, so this is 2 2s are, and the displacement therefore is given by 2 divided by 5, right? And this is minus 0.4. So the work done is negative, and therefore when you supply negative work to the body loses the kinetic energy and comes to a standstill. Okay, so the work energy translation is a very important concept that you must learn. But to do that, you should first attempt these questions where you have clarity on what is the direction of the force and the displacement. Because finally, the questions will become like these, where a work is done or a force is being applied on the body. Either it is accelerating the body or decelerating the body. It is increasing its potential energy or decreasing its potential energy. I hope this made sense. A very important thing to do in physics is being able to complete the assignments in time. If you don't do your assignments, it's rather difficult to learn physics. Okay, so concentrate on your assignments. They help you retain, and practice makes most of the time you a perfect student. So thank you very much for your time. Share this video with your friends and watch my playlist on vectors. Watch my playlist on work power energy. You will see some amazing videos being solved for IB board, for A level and IGSC. Thank you very much for your time today, and wait for my next video.